Hello everyone, myself Ashwati Rajan, Assistant Professor, Electrical and Electronics Engineering Department, Jyoti Engineering College. My topic is electrical safety of medical equipments. The patient in the hospital is the center of care and should consider the patient's safety as well as operators and others' safety. The electrical safety is very important element in the hospital safety. The electrical safety of the medical equipment in the hospital is the most important of it. Then rules for the electrical safety of medical equipments. The equipments connected to a patient to be powered from one socket or a block of sockets having the same protective grounding points. All the metal subjects in the vicinity of the patient to be grounded one at a time with the same protective ground point, and patient to be connected to a common ground through only one grounding pole. Isolation amplifier to be used for the measurement if possible, and avoid using materials which can be charged electrostatically, and deal carefully with electric wires and sockets and let it be checked periodically. Do not use extension cables, do not use faulty cables and plugs. And equipments, if an equipment have a failure which can cause electric shock, uh, it has to be taken for our service immediately. If we are touching any metallic surface of an equipment, if we sense electric shock, then plug off the equipment immediately and ask for check, because this equipment is either badly earthed or not earthed at all. Do not use any medical equipment you do not know the basics of its operation and it not read its instructions manual carefully. Next one, macro shock. In macro shock, the external applied current spread throughout the body. It is defined as the passage of current from one part of the body to the another. Next, microshock. The current affected heart directly through pacemaker leads or catheter. The current less than 100 microampere have the potential to cause VF. VF means ventricular fibrillation. It is possible from 25 microampere. So from 25 microampere to less than 100 microamperes, we may cause ventricular fibrillation due to the shock. And ventricular fibrillation is a completely irregular asynchronous heartbeat. No synchronism in ventricular contraction and blood flow stop, and if such heart work does not stop, it leads to death within a few minutes. And physiological effects of electrical current. The contact with electrical current can have various effects on the human body, such as pain, burn, or even death. There are many factors which affects the way the body interact with the current, such as skin resistance, the voltage, the length of time of contact, and the amount of electrical current and its intensity. The body is extremely sensitive to the effect of electric current. Firstly, it disturbs the normal operation of our nerve and muscle systems. The other reason, when current passes through the body, it is transformed into thermal energy. It can cause serious burn both inside our body and on our skin. The current of about 10 milliampere can cause a very painful shock. The amount of current passing through the human body depends on two things: the voltage supplied by the source and the electric resistance of our body. The resistance value of our body, if it is dry skin, it is 100K to 600K ohm. Wet skin, 1 kilo ohm. Hand to foot, 400 to 600 ohm. Ear to ear, 100 ohms. And general effects of electric current. Electric current contact for 1 second. If it is below 1 millisecond, no sensation, probably not noticed. If it is 1 milliampere, mild sensation, not painful. And if it is 5 milliampere, slightly shock, not painful. An average individual can let go. and 6 to 25 milliampere for women, painful shock, loss of muscle control, and 9 to 30 milliampere for men, freezing current and cannot let go. The person may be thrown away from the uh, powerful source. And 50 to 150 milliampere extreme pain, respiratory arrest, muscular reactions, possible death. 1 to 4.3 ampere fibrillation of heart, muscular contraction and nerve damages occurs, likely death. 10 ampere cardiac arrest, severe burn, death is possible. And different effects of AC and DC. The effect of AC or alternating current depends on the frequency. If a low frequency is much more dangerous than high frequency. AC with the same ampere and voltage as DC is more dangerous and provoke worse effects on the human body. A low frequency AC provokes muscle contraction, which can include cannot let go effect by freezing the muscles of the hand. And AC has a tendency to induce heart fibrillations, which DC makes heart stop. This is why defibrillation equipments are mostly in DC, which stops the heart and gives chance to recover. Method of accident prevention. There are different methods are there. First one is grounding of electrical system. For the protection, most frequently using method is proper grounding. The principle of this method is to be make the grounding resistance Rg a small enough that's for all possible values of fault resistance Rf. The majority of the fault current bypass the body of the victim and the body current remains at the safe level even if the contact and body resistance are small. And second one, double insulated equipment. In a double insulated equipment, the case is made of non-conductive material like plastic. If the equipment is metallic type, the main body of the equipment separated by insulation. Double insulated equipment is need not be grounded and labeled as double insulated. And protection against both macro and micro shocks are possible in double insulated equipments. And operative at low voltage. Operation at low voltage. The low voltage equipments are generally safe than high voltage equipment. So we can use battery operated equipments and does not have to be grounded. And fourth one, the ground fault circuit interrupter. Most electrical accidents take place when the body provides a conductive path to the ground. Normally, all the current that enters the device through the hot wire returns through the neutral wire. In the case of an accident, a part of current actually returns through the body and through the ground. In the ground fault circuit interrupter, the difference between the current in the hot and the neutral wire of the power line is monitored by a different transformer and an electronic amplifier. If this difference exceeds a certain value, usually 5 milliampere, the power is interrupted by a circuit breaker and the interruption occurs so rapidly that even in the case of a large current flows through the body, no harmful effects are encountered. And fifth one, isolation of patient connected parts. Medical equipments are using mainly for measuring the electrical potentials like ECG, EMG, EEG, etc. or to apply electrical signals such as in electrical pacemakers. These electrical connections sometimes may create dangerous situation for the patient if the equipment does not work properly. A modern medical equipments like ECG machines, there is an isolation between patients' leads from ground by the use of isolated input amplifier or use battery operated type equipments. Thank you.